Hello viewers, welcome to video number 115 of the channel MALACHEMPHILIC, and video number 115 is the 55 episode of Chemical Thermodynamics. Topic of this episode is relation between Gibbs free energy change and equilibrium constant. So let's start. So our topic is relation between Gibbs free energy change, that is delta G, and equilibrium constant, that is K equilibrium of a reversible reaction. Now let us consider a general reversible reaction where all the reactants and products are ideal gas. Okay, so let us take the reaction. Say A moles of A plus B moles of B. The product is M moles of M plus N moles of N. Okay. Now, for this reaction, say, what can I write? That Cg, that is Gibbs free energy of the reactant, that is equal to what it will be. Already in my last video I told, I have derived G is equal to N1 mu1 plus N2 mu2, like that. So same thing will apply here. Here number of mole is A, so A mu A plus B mu B. Okay. Similarly, free energy of the product, what can I write? That is M mu M plus N mu N. We can write. So delta G of the reaction, I can write it as G of the product, free energy of the product, minus free energy of the reactant. We can write it. Okay. So delta G reaction, what we can write now? Just I'll put it in this equation. G product means this one, that is M mu M plus N mu N minus reactant is A mu A plus B mu B. I can write it. Okay. Now we know that mu, already I have derived, mu is equal to, say mu of any component, say mu I is equal to mu I0 plus RT ln concentration. Say I am taking the molar concentration Ci. So Ci molar concentration. Okay. This relation already I told you in my earlier video. Now, so this one already we know, right? Now, so what we got? G reaction is equal to, I'll write down this one once again, that is delta G reaction is equal to M mu M plus N mu N minus A mu A plus B mu capital B, right? Now, in place of m mu, I'll put it as per the equation mu is equal to mu 0 plus RT ln concentration. So, what we can write? Delta G reaction is equal to, okay, m. Mu m means mu m0, that is chemical potential in the standard state, plus RT ln Cm, molar concentration of this m, okay, that is product m, plus n, mu 0 n plus RT ln Cn. So this is from the product side, minus then A. Once again, in place of mu A, I can write mu A0 plus RT ln Ca plus B mu B0 plus RT ln Cb, molar concentration of B. I can write. Okay. Just I'll do the simplification. So, delta G reaction, that will be is equal to, now see here, this part. How can I write? I can write m mu m0 plus RT ln Cm to the power m, I can write, because log a to the power b is equal to b log a. So it is multiplication, it was there. So I have written it as power. Okay, fine. Then plus, same way this one, that is n mu 0 n plus RT ln Cn to the power n. This is from the product side, minus, here also I can write like that, A mu A0 plus RT ln Ca to the power A plus B mu B0 plus RT ln Cb to the power B. I can write it. Okay. Now, so delta G reaction, that is equal to, what I will do, I will take all this mu m0 and mu n0, all this part together, and RT ln concentration part together, right? Then what it will be? It will be here m mu m0 plus n mu n0, right? Okay. This plus this, minus A mu A0 and then minus B mu B0, right? Then plus, now this term I'll take together, that is RT ln Cm to the power m plus, we can take RT common, okay, next line I'll take RT ln Cn to the power n minus RT ln Ca to the power a minus RT ln CB to the power B. We can write. Okay. Now we know that G is equal to, already I told you, we have derived also, G is equal to N1 mu1 N2 mu2 like that. Okay. So this is M mu n0 plus N mu n0. How can I write this one? This one I can write it as delta G reaction, that will be is equal to, so this one will be is equal to my G0 product, this part, minus G0 standard free energy of reactant. We can write it. Okay. Now this is then plus. Look at here, if I take RT common, then ln Cm to the power m plus ln Cn to the power n minus ln Ca to the power a minus ln Cb to the power B. So log A plus log B is equal to log A into B minus, say, log C divided by Ca. That means what I can write here, RT ln Cm to the power m, Cn to the power n, because these two are plus, it will come as multiplication, then this two will be minus. So as a division it will come down. That means Ca to the power A, Cb to the power of B. Okay. So next line I can write it as, from here I can write it as delta G reaction is equal to delta G0 product, standard free energy product minus standard free energy reactant. That means delta G0 of the reaction plus RT ln Cm to the power m, Cn to the power n divided by Ca to the power A, Cb to the power B. You can write. Okay. Now, so it is delta G reaction, that will be is equal to delta G0 reaction plus RT ln Q. Q is this ratio, product is to reactant. So here Q is equal to Cm to the power m, Cn to the power n divided by Ca to the power A, Cb to the power B. Okay. And Q is known as reaction quotient. Okay. Now reaction quotient means at any stage of that means this concentration we can take at any stage of the reaction, not necessary when the equilibrium is reached, right? So when we will write Q, that indicates this concentration of the product and reactant, they are taken at any stage of the reaction, right? Okay. So this is one important equation. Delta G is equal to delta G, that means delta G of reaction is equal to delta G0 reaction plus standard free energy change plus RT ln Q. Now from this reaction, say So this I'll put it as equation number. So this is my number 1. Okay. Now from equation 1, what we can write? When Q is equal to 1, reaction coefficient is 1, then delta G is equal to delta G0. Okay, this is one relation. Delta G is equal to delta G0. Now, at equilibrium, now coming to equilibrium. At equilibrium, what is that? Delta G, free energy change will be equal to 0. Okay. Then from equation 1, what we can write? 0 is equal to delta G0 plus RT ln equilibrium constant. Okay, it is an equilibrium. Then at equilibrium, this Q is equal to K equilibrium. Okay, that means at equilibrium, or when delta G is equal to 0, that is the equilibrium condition, then this reaction quotient Q is equal to equilibrium constant. This is the equilibrium constant. Equilibrium constant. Okay. Now from this equation, what I can write? I can write it as delta G0, standard free energy change of the reaction. Okay. That will be is equal to minus RT ln K equilibrium. So this is the important relation. This is the important relation. Okay. Now, as I have taken that reactants and products are ideal gases, so since reactant and products are ideal gases, then the concentration can be expressed in terms of the partial pressure of the reactants and products. Okay. Then what we can write? In that case, delta G0, that will be is equal to minus RT ln, this we denote it as Kp, equilibrium constant, and concentration in terms of partial pressure, right? So this is the relation between this Gibbs free energy change and this equilibrium constant. So delta G of the reaction, that is equal to delta G0, standard Gibbs free energy change, plus RT ln Q. Q is the ratio of this product and reactant. This is known as reaction quotient. But then the concentration can be taken as any stage of the reaction. But equilibrium constant means when the equilibrium is reached, that means you have to take the concentration of the product and reactant at equilibrium. So at equilibrium, what is the concentration of the reactant and product? That you have to put it in this equation. Then it is K equilibrium. So this is the relation between this Gibbs free energy change and equilibrium constant or reaction quotient or equilibrium constant. Hope you have understood. Thank you.